During Tesla's recent earnings call update letter, the company's CEO Elon Musk revealed that Tesla's highly awaited all-electric commercial truck, the Tesla Semi, would be delayed once again due to supply chain disruptions and battery cell constraints. However, Mr. Musk made a rare comment about the Tesla Semi's range and efficiency, which is going to be vital to the success of the truck. The electric automaker claims that the Tesla Semi will be able to reach an efficiency of over 0.5 miles per kilowatt-hour and boast more than 500 miles of driving range. This seems to match with what the company announced at the original launch of the electric truck. The company said that the Semi would boast an efficiency of over 2 kilowatt-hours per mile. With this estimated range and efficiency, one would wonder how the Tesla semi-electric truck would actually achieve these impressive figures by charging its massive 4680 battery packs very quickly. Well, one way to simplify and speed up the charging process could be to develop a faster and more efficient inductive wireless charging system. And one company that says it can deliver such a solution is a US-based wireless charging specialist called Wireless Advanced Vehicle Electrification, WAVE. WAVE, now a subsidiary of Ideanomics, proposes a high-speed induction charging system that would add juice into the Tesla Semi at speeds up to 500 kilowatts or even 1 megawatt, and without any physical connection. In most recent press release, WAVE announced that it had been developing high-power wireless charging solutions for heavy-duty vehicles, and the Tesla Semi may be one of the first electric vehicles the company will utilize to carry out the testing of the technology and later offer a commercial charging solution vehicle. Currently, WAVE has offered charging solutions with its primary 250 kilowatt business. The company claims that its extreme fast charging systems can transfer up to 250 kilowatts for bus charging, for instance. However, it aims to develop a 500 kilowatt and 1 megawatt induction charging system, void of cables and wires, but with a primary coil embedded directly into the parking lots or roadways, adding range to the trucks through a receiving coil. As the company explains, the power would then be transferred from both the main and receiving coils using magnetic fields energized by a resonant inverter. The high-frequency AC currents from the coil underground would send power to the truck's plate that can be between 10 inches and 25 centimeters away. The current state-of-the-art drayage truck charging features primarily conductive chargers. The recently announced Tesla Semi concept design has the largest advertised range of 500 miles, with a target of 80% charge in 30 minutes. The battery pack is estimated to be at least 800 kilowatt-hours maximum and must have a target charge rate of approximately 1.5 megawatts, WAVE stated. The system under development by the United States Department of Energy contract of charging an electric drayage truck at extreme fast charging power levels will be the fastest charger by a significant margin, it added. We already know that Tesla has been working on its solution and has teased us with jaw-dropping specs ahead of the Tesla Semi's release. This type of charger also makes a lot of sense for Tesla's electric haulers, considering that they demand extremely powerful chargers in order to charge their massive battery packs within a short period of time. When the Semi was first unveiled back in 2017, Tesla's boss Elon Musk said that the company would install a network of solar-powered megachargers at a Frito-Lay delivery center in Modesto, California. The Tesla megachargers would require a high energy output of over 1 megawatts in order to add 400 miles of range in less than half an hour. Mr. Musk also noted that these megachargers would use liquid-cooled connectors to control their temperatures. It's worth noting that the automaker also uses similar technology in its V3 superchargers. With Tesla's supercharger network, adding wireless charging to the mix will make it even more attractive for customers, as it will alleviate their range anxiety. However, it is important to remember that the WAVE technology is not the only form of wireless power transfer to electric cars. There are also dynamic wireless electric charging stations. In contrast to the WAVE technology that presupposes that electric vehicles rely on resonant magnetic induction to transfer energy between two charging pads, one embedded in road surface and one on the underside of the vehicle. Dynamic wireless electric charging stations are also embedded in the roadways, but charge electric vehicles as they travel over them. While dynamic wireless electric charging stations are ideal for charging electric cars that cannot afford to stop and spend a lot of time at a charging station, they compromise efficiency and reliability. Wirelessly charging big batteries at high speed is risky. It can cause overheating with a continuous discharge and charge from the charging port and receiver. Moreover, dynamic wireless electric charging stations reduce the lifespan of the charging port as well as a car battery. Additionally, dynamic wireless electric charging stations reduce the lifespan of the charging port as well as that of the car's battery. Another challenge for dynamic wireless electric charging stations is rectifying the coupling between the charging port and the car. If an EV is slightly misaligned due to irregular parking or traffic, still the transmitter should be more powerful to inductively couple with the receiver. However, this problem can be solved by improving the layout and design of both the mat and the receiver. A movable receiving coil can be used to enable charging of 5 kWh and an efficiency of 90%. All in all, Wave has confirmed that its high-speed induction charging points won't only be reserved for medium and heavy-duty vehicles, but they will also be compatible with smaller electric cars. Wave is exploring plans to install them along busy transit routes such as in urban centers. Already, the company has some operational wireless charging infrastructure in Utah and Washington. Mr. Musk also made another rare new comment about the truck's weight in the company's 2020 impact report. The EV maker said that the Tesla semi-truck's payload would be comparable to a Class 8 diesel truck. Initially, critics of the Tesla Semi underestimated the battery tech advancements, and they believed that the truck was impossible to produce due to weight capacity limitations. Though the maximum weight load capacities may vary, on average, the limit for heavy-duty Class 8 trucks is 80,000 pounds in the United States. This weight load capacity includes the weight of the truck and its payload. The weight of battery packs determines how much an all-electric Class 8 truck would be able to carry. In simple words, the lighter the battery, the more payload an electric Class 8 truck boasts and vice versa. Considering that the payload is what makes trucking profitable, there have been some concerns that all-electric heavy trucks would be heavier and therefore they would be completely uneconomical to carry lighter loads. However, Tesla CEO Elon Musk previously confirmed that the Tesla Semi weighs 1 ton less than diesel-powered trucks, which on average weigh about 17,000 pounds, 8.5 tons. In 2017, some car experts concluded that Tesla would require battery packs of ratings between 600 kWh and 1000 kWh for the 300 and 500-mile range versions of the Tesla Semi. And considering that Tesla's 100 kWh battery packs weigh approximately 1,300 pounds, so a 600 kWh pack would weigh around 8,000 pounds. Fortunately, the automaker has made tremendous advancements in battery technology since the truck was rolled out. The company introduced the 4680 battery cells, which it claims are lighter but boast a higher energy density. The Tesla's 4680 cells could therefore lower the overall weight of the electric Semi. Apart from advancements in battery technology, the trucking industry itself has also transformed since 2017. For instance, the European Union and the United States are now reviewing regulations regarding electric cars and trucks. The automaker revealed in its impact report that the US and the EU approved weight allowances of 2,000 and 4,400 pounds respectively. The Tesla Semi's production has been delayed for several years since its 2017 unveiling. Tesla's CEO has acknowledged that battery cell constraint is one of the main challenges causing the delays in the Semi's production. A year after the pandemic, the global computer chip shortages contributed to the disruption in the production of the truck as well. If these recently revealed specs do prove accurate, then the Tesla Semi could enter the trucking industry that is lucrative and ripe for disruption. All electric commercial trucks exist today after all, but very few or none could be considered comparable to the Tesla Semi when it comes to performance, battery or range, and the average cost per mile. Make sure to check out one of the videos shown on your screen right now. We post videos daily, so feel free to subscribe and stay up to date on all most recent news and updates.